Every time you ask an AI question, generate an image, or write a few lines of code, somewhere in the world, a data center is burning through massive amounts of electricity. And as generative AI explodes in popularity, power grids across the globe are starting to feel the strain. So the question is, can our energy infrastructure keep up with artificial intelligence? Welcome to Process Protocol, where we break down the systems shaping the modern world. Typing a prompt into an AI like ChatGPT or Midjourney feels instant and effortless. You hit enter and seconds later, you get a response. But behind that simple interface, a storm of activity is unleashed. Your request triggers a cascade of complex calculations across thousands of high-performance chips, all working in unison. Each one of those responses requires massive server clusters, advanced graphics processing units, or GPUs, and continuous powerful cooling systems, all of which consume a significant amount of electricity. To put it in perspective, a single AI query can use several times more energy than a traditional Google search. It's the difference between flipping a light switch and turning on a stadium's floodlights. This hidden cost, multiplied by billions of daily prompts worldwide, is creating an energy demand unlike anything we've seen before. To meet this exploding demand for generative AI, companies are building new data centers at a record-breaking speed. We're talking about a construction boom on a global scale. Tech giants are pouring billions upon billions of dollars into AI infrastructure. They are rebuilding new chip factories to produce the specialized hardware AI needs and constructing massive server farms, sprawling complexes that house the brains of the AI revolution. Some of these new facilities are so vast and power-hungry that they require as much electricity as a small city. Imagine an entire town's worth of power being dedicated solely to answering questions and creating images. That's the scale we're dealing with, and it's growing every single day. So why exactly does AI use so much power? It comes down to the fundamental technology behind it. Generative AI relies on what are called large language models and neural networks. These are incredibly complex systems designed to mimic the human brain structure. These models contain not millions, but billions, and in some cases, trillions of parameters. Think of them as digital neurons. To run, they require specialized GPUs, which are far more power-intensive than the standard processors in your laptop. These GPUs are designed to process huge amounts of data simultaneously, which is essential for the complex calculations AI performs. The training phase alone is staggering. Training a single large AI model can consume millions of kilowatt-hours of electricity, enough to power hundreds of homes for a year. And even after it's trained, the model still requires constant, uninterrupted power to be online and ready to serve user requests around the clock. But it's not just the computing power that's the problem. All those processors running at full tilt generate an enormous amount of heat. If you've ever felt your laptop get warm while running a demanding program, now imagine that on an industrial scale, with tens of thousands of chips packed together. To prevent these servers from literally melting down, AI data centers rely on colossal cooling systems. We're not talking about a few fans. We're talking about industrial-scale air conditioning, liquid cooling loops that pump fluids directly over the processors, and in some cases, massive water-based cooling towers. This cooling process is itself incredibly energy-intensive. In many regions, these data centers have become major consumers of not just electricity, but also water, putting a strain on another vital resource, especially in arid locations. With new power-hungry data centers appearing almost overnight, local power grids are starting to feel the pressure. Utility companies in several countries are reporting sudden, unexpected spikes in electricity demand. Why? Because these AA facilities are unlike any other industrial customer. They don't operate on a 9-to-5 schedule. They require a constant, high-level, uninterrupted supply of power 24 hours a day, 7 days a week. Any fluctuation or outage can disrupt services for millions and cost companies a fortune. Many of our existing power grids were built decades ago and simply weren't designed for this level of continuous, concentrated industrial demand. They were built for a world of predictable peaks and troughs, not a world with digital factories that never sleep. This is forcing utilities to scramble, accelerating upgrades, and, in some cases, even pausing new connections to prevent the entire system from becoming unstable. This sudden, insatiable hunger for energy has sparked a new kind of gold rush. Tech companies are now in a frantic race, competing not just for talent and market share, but for energy contracts. They are aggressively securing power for their future data centers. This involves building their own dedicated solar and wind farms to generate clean energy and signing long-term power purchase agreements, sometimes with nuclear power plants, to guarantee a stable, carbon-free supply. They are also investing heavily in next-generation energy solutions like geothermal power and advanced battery storage. In some extreme cases, entire power plants are being planned or repurposed specifically to power AI infrastructure. The competition for electricity is becoming a key strategic battleground in the tech industry, reshaping energy markets around the world. So we have this incredible technology that promises to automate tedious tasks, accelerate medical breakthroughs, fuel new scientific discoveries, and unlock massive productivity gains across every industry. But this promise comes with a significant trade-off: a rapidly growing carbon footprint. The environmental implications are a serious concern. If the demand for AI continues to rise at its current trajectory, the energy consumption from data centers could double or even triple over the next decade. This will put immense pressure on global climate goals. The challenge is crystal clear. Can the exponential growth of artificial intelligence be powered sustainably? Or are we trading one problem for another, solving complex challenges with AI while simultaneously accelerating climate change? The answer to that question will define the next era of technology. Fortunately, the industry is acutely aware of this challenge and is already working on solutions. The race is on not just to build bigger AI, but smarter AI. This includes designing more energy-efficient chips that can perform more calculations per watt of electricity. Researchers are also developing smaller, optimized AI models that can achieve impressive results without the colossal energy footprint of their larger counterparts. On the infrastructure side, there's a massive push towards building renewable-powered data centers, integrating solar, wind, and other green sources directly into their operations. Companies are also pioneering advanced cooling technologies, like liquid immersion cooling, which is far more efficient than traditional air conditioning. The goal is simple, yet incredibly ambitious: to achieve more intelligence with less electricity. Artificial intelligence is transforming the world at incredible speed. But behind the innovation lies a massive, often invisible demand for energy. The future of AI won't just depend on smarter algorithms, it will depend on smarter power systems. If you want to understand the processes shaping technology, infrastructure, and the modern world, subscribe to Process Protocol. Because behind every innovation, there's a system powering it. Thanks for watching.